Hello students, our today's topic is velocity. My dear students, the rate of the change of the position of a body in a fixed direction is called its velocity. That is, velocity is equals to final position minus initial position by time interval. It is expressed mathematically as v is equals to final position xf minus initial position xi by time interval t2 minus t1, or v is equals to xf minus xi by t, where t shows the time interval, xf is the final position, xi is the initial position. Okay, velocity can be also defined as the displacement per unit time. Displacement per unit time, as we know that displacement is equal to change in position, that is final position minus initial position. So the final position minus initial position itself indicates the displacement, right? Therefore we can define as velocity of a body is the displacement per unit time, that is velocity equals to displacement by time, or v is equals to s by t. Here the arrow is put on V and S both. This arrow shows that these are the vector quantities, that is they have magnitude as well as direction both. In generally, we do not represent the velocity in terms like that putting arrow, but if it is expressed in vector notation, then it is compulsory to put the arrow mark. Okay, so just you see that V is equals to S by T is equal to xf minus xi by t. Now there are some features of the velocity. Velocity of a body has both magnitude and direction, right? It has magnitude as well as direction both. Therefore, it is a vector quantity. Velocity of a body may be positive, negative, or zero. If you compare the velocity with the speed, then you will say that the speed is only positive or zero. But here, the velocity of a body may be positive, negative, or zero. I will explain it in detail by taking an example. Next is SI unit of the velocity is meter per second. SI means International Standard Unit, and other units are centimeter per second, kilometer per hour, etc. Next, velocity of a body changes due to its magnitude or direction, or due to both. Either if its velocity of a body changes, either its magnitude is changed or its direction is changed, or both are changed. Now we take an example. Suppose a car A travels from P towards Q, and the same time another car B travels from Q towards P. So their direction of motion is just opposite to each other, right? Let their speed is the same, that is 10 meter per second. Then what is our conclusion about the velocity? The velocity of car A is if 10 meter per second, then the velocity of the car B is minus 10 meter per second. Okay, this is due to the change in direction. In next one is, this is because their magnitude is same but their direction is opposite to each other. Next, if a body moves on a circular path with the uniform speed, say let 5 meter per second, then if we consider 2 points A and B on the circular path, A and B are the 2 points at the end of the diameter, right? Such that A and B lie at the end of the diameter, Then if the velocity of object at point A is 5 meter per second, here if the velocity is 5 meter per second, then what will be its velocity at this point? This is now minus 5 meter per second. This is because here the direction is towards right hand, but here the direction of motion is towards the left hand, right? So these in these two opposite position, the direction of motion is just opposite to each other. Hence, though their magnitude is the same, but due to change in the direction, the velocity is different. Okay, so in first case it is positive and second case it is negative. Okay, now what will be the velocity of the object in one complete round? So what will be the velocity if the object completes one round? Then what will be its velocity? So let us first find out what will be its displacement after one round. Net displacement will be zero because the body comes to the same position. Therefore net displacement is 0. And if the net displacement is 0, then velocity is equals to 0. Okay, so it is clear that velocity of a body may be 0 whether it is moving with a constant speed on a circular path. Now types of velocity. First is the uniform velocity. If the displacement of a body is equal for equal interval of time, howsoever small interval of time may be, then its velocity is called the uniform velocity. Okay, if the displacement is always equal with equal time interval, whatever the small interval of time may be, then its velocity is called uniform velocity. For example, a car moving on a straight road with a constant speed. So here its displacement is equal for equal interval time, therefore its velocity is uniform. Next is non-uniform velocity. If the displacement of a body is not equal for equal interval of time, then its velocity is called the non-uniform velocity. So if a body moves on a zigzag road and its maybe speeds uniform, but as the direction changes continuous regularly, therefore its velocity will be non-uniform velocity. Okay, next is average velocity. What do you mean by the average velocity? If the velocity of is non-uniform, then the ratio of the total displacement to the total time taken is called the average velocity. Right? Means the minimum separation is called displacement. So in what way your movement is, that doesn't matter. We calculate only here that what is your displacement. So displacement per unit time is called average velocity. It is denoted by VAB. So VAB is equals to total displacement by total time taken. We can also define the average velocity by taking another case. If the velocity of the body changes at a uniform rate, then the arithmetic mean of initial velocity and final velocity of given time period is called its average velocity. Once again, if the velocity of a body changes at a uniform rate, then the arithmetic mean of the initial velocity and final velocity for a given time period is called its average velocity. Average velocity is equal to initial velocity plus final velocity by 2, or VAB is equals to U plus V by 2. So this is the arithmetic mean of the initial velocity and final velocity. Arithmetic mean of the initial velocity and final velocity. Okay students, so just these are some types of the average velocity. I will share some questions in the next video. Thank you.